Hello everyone. This is the continuous part of the section 8.4. For this moment, you should have your book and open to page 108, and then we will continue the factors affecting resistance. If you remember that the resistor will affect the size of the current, so that if I change the resistor, the current will be changed. So if you still remember a higher resistance of a resistor, the current will be smaller. Okay, based on this factor, we should learn that if we change the resistance of the resistor, you can control the current. So before, for the first lessons you have learned, we did change the materials of the wire, so that you can find that as the resistance of different wire has different resistance, so we can change the current. In the second experiment is the thickness. Okay, the thickness, if we use thicker or thinner wire, we can change the size of the resistance in order to change the size of current. So now for this lesson, we will change another factor, that is the length of the wire. Okay, what is going on when we change the length of the wire? If it is longer or it is shorter, will it affect the resistance to be higher or lower? That means, does a longer wire have a higher resistance? For each experiment, we all know that we have three factors. That is independent variable, dependent variable, and controller variable. Okay? If you still remember, you have learned in Form 1, independent variable is the factor you change. Dependent variable is the factor you are going to measure. For controlled variable is the factor you should keep constant. So remember that you change is the independent variable. You measure is dependent variable. You keep constant is the controller variable. Okay, from this experiment, you all know that we want to learn different length of a wire. How can it change the resistance? And then in order to change the current. So for the change, you can change is obviously is the length of the wire. Okay, please write down in your textbook. For dependent variable, what is going to measure? Okay, when you change the length, you should want to see the current, how the size will change. So is the current flowing through the circuit. Okay, if you remember that the current, what apparatus can we use to measure the current? That's right, is ammeter. Okay, remember that, ammeter. Okay, for controller variable, it should be the variable you keep constant. So for the length, you should not choose, right? Because it's the independent variable. So the number of cell, how much energy you provide, the material of wire, and thickness of wire should be keep constant. Okay. So now we have to move to design of the experiment. Now you should know that we have used a circuit board. Okay, cells, 2 or 3 cells, wire, nichrome wire, you are going to change the length, an ammeter, right? So for this circuit board, we can see that an emitter here, 2 cells, a nickel wire, okay, all are connected in this way. So I want to remind you that for this 2 cell, there should be positive end to negative end. And when it connects to an emitter right here, it should be positive to positive. Okay, for other connection, there is no positive or negative pole, but for the emitter, you should connect the positive knob to positive terminal of the cell. Okay, and then for this wire, for this nickel wire, we can use 50 centimeter long. I remember that in the laboratory you can even use longer. So that is not the problem. You just change the length of the wire from 50 to 40 or 50, okay, and so on. So when you change the length of the nickel wire, obviously the emitter, the current flowing through the circuit will change. So we measure the data from this circuit board. So now try to write down the procedures. Connect the circuit as shown. Put the two clips onto the nickel wire so that they are 50 centimeter apart. For this length, you can change. Close the switch and record the current measured by the emitter in the table in step 3. Okay? And then move one of the clips so that it is 10 centimeter closer. For this reading, you can change to 5 or even 2 to make it more accurate. So repeat step 2 until 5 sets of data. 5 sets of data means 50, 40, 30, 20, and 10. Okay, for a table, remember you should have a title at the bottom of the table. Okay, and for each item, remember to write down the unit. So if you write down the unit right here, you don't need to put in each column. It is unnecessary. Okay, remember that all the units right here is enough. Okay, when at the experiment, I will add the clip to you. You can see the video on the link, and after that, you can find you need to draw a graph. Okay, every time when you draw a graph, you have x-axis and y-axis. Okay, how can we decide which item is x-axis, which one is y-axis? Remember that the graph you have to draw is the table, the item on the table, length of the nickel wire and the current. Then the length of the nickel wire is right on x-axis or y-axis. Let's see. There is a rule we should follow. For the x-axis, we always write the independent variable. For y-axis, we should always write down the dependent variable. Just like this. Okay. For a graph, when you write down the x-axis and y-axis, first of all, remember you should write down the information. If it is more clear, you should write down the length of nichrome wire. Okay, it is more clear. Okay, instead of L. And then bracket cm. For this size, you should write down current and bracket A. Okay, this is more clear. And for each scale should be equal in length. Okay, here is equal in length. And then 0 must be written down. Any question? So when you draw a curve, you can see that there are many rules you should follow. And then for the title, a better title is not the current against length. The better title should be the graph showing the current in different length of nichrome wire, just like the title. Okay, this is better for you to understand how to draw a graph. So what is the use of the graph is when I want to know if the length is changed to 25 centimeter, you can use a line to find out what is the current when the length is at 25 centimeter. That should be around 0.3 ampere. Okay? So what is the conclusion you can draw from the graph? Okay. Now, when you find that when the nichrome wire is 10 centimeter, the current is 0.6. Okay. When it is 50, it is 0.19. I just use these two sets of data, and then you can find that when the length is longer, the current is smaller. Okay, so when the resistance is larger, that means the length is longer. The length is longer. The length of the nichrome wire is longer. It will make the resistance larger, so that the current will be smaller. Okay, so the conclusion will let you know that the longer the wire, the smaller the current. In other words, a longer wire has a higher resistance and it will make the current lower. Okay, so for the conclusion for this section, what is the factor affecting resistance is we have three factors. One is the length. The longer the length, the larger the resistance. 2. The thickness of the wire. The thinner the wire, the higher the resistance. And the third one is the material use. The material use depends on whether the materials has higher resistance or lower resistance. That means that it is a good conductor or not a good conductor. Okay, not a better conductor. Okay, so for a wire made of same material, that means the controller variable is the same. A thin wire has a higher resistance than a thick wire. A long wire has a higher resistance than a short wire. Okay, then that is the end of our lesson. Bye bye.